What's going on, you guys? Today's video is going to continue our discussion about histograms. In particular, we're going to talk about looking at a histogram and then kind of describing its shape, center, and spread. We'll be on binder pages 381, 386, and 387. But before we do that, just kind of want to look at an example here of a histogram. This histogram shows the household income in America. So $5,000 categories. So each of these bars represents $5,000 for household income. And so what we can see here, if you look at the very far left, the first bar is 0 to 5,000 would be 3.5%. So 3.5% of people in America have a household income between 0 and 5%. So this, if you remember our discussion from the video before this about symmetric and skewed distributions, this would be an example of a distribution that's skewed right. We have the tail that goes way off to the right. Most of the data is on the left here. Now, when we talk about household income, the stat you'll hear most often is the median household income, and you can even see it pointed out on this chart here. The median income is $49,445. I think this data is from, doesn't give us a year. I think I remember I saw it was from around 2014. So it's a couple years old, but it's not terribly outdated. Anyway, why do we talk about the median household income instead of the mean or average household income? Well, the reason is because the data is skewed, there are all these outliers over here. And those outliers would bring the mean way up. So a better way to describe the typical household income is by using the median, because it's not as impacted by outliers. What it means is half of American households have an income less than $49,000, and half of American households have an income more. So that's kind of what this video is going to be about, is when we have a distribution, a histogram that is approximately symmetric versus one that's skewed left or right, how do we describe the center and spread of that histogram? So turn to page 381 in your binder. And, we looked at this page in the last video, but we're going to kind of focus in on this flow chart at the bottom. So when we're describing the data, you're going to kind of go through this thought process for yourself. And this chart here is a great thing to kind of remember. Is the data symmetric is your question. So if it is symmetric, you're going to go to the right side. And on the right side, we are going to describe that data using the mean and standard deviation, because they are symmetric means no outliers or very few outliers. So the mean and standard deviation are good descriptors of the center and spread. Okay, but if the data is not symmetric, if there are outliers, then we are going to follow the left side here and use the mean and the IQR. Right? And we do this because outliers impact the mean and standard deviation but not median and IQR. So median IQR become a better measurement, a better descriptor of the typical or the center of the data and the spread of the data. Okay, jump ahead to page 386 now. Yes, 386. All right, on this page here, we already filled out the top with kind of that skewed left, skewed right, symmetric. So here is an example of one type of problem we'll see. All right, in this problem, we're given a distribution, okay? And our job is to kind of fill in the blanks here in this little paragraph that describes it. So one of the things you've got to actually do is look at the histogram and decide what it is actually describing. So you look at the x-axis and it looks like we are describing points. Maybe that's points scored in a game. And so the first blank here, the distribution of subject, you're going to use what is being measured. So in this case, the distribution of points is, and then here we describe the shape. Okay, this shape, it appears to be skewed right, because there's more data on the left, the tail goes off to the right. So this data is skewed right. And if it's skewed right, that means it's not symmetric. So if you think back to your flow chart, when it is skewed, we want to use median and IQR. Okay, so skewed, median, IQR. So with a center, well, the center that we're going to use is the median, with a median of, and I'm going to go off to the right here, it shows me all the information. The median is 26. 26 points. And notice it says value with units, so we have to say points. And a spread, okay, the spread that we're going to use is the IQR. So an IQR of, and now I have to actually calculate it, IQR equals 34.5 minus 17, Q3 minus Q1, and that's, I think, 17.5. So an IQR of 17.5 points. Okay. What that means here, the median points scored is 26. Half the games are below that, half the games are above that. And the IQR represents, again, that's going to be the middle 50%. So it tells you that the middle 50% of games was spread out by about 17.5 points. All right, let's do one more. Next page. Okay, number 12 here up at the top. Complete the description, including shape, center, and spread. In this case, we're measuring student heights. So it's a distribution of student heights. The distribution of heights is, I would say this one's approximately symmetric. Okay, it's pretty well balanced. There's that one little kind of oddball one right there, but overall it's pretty much the same on the left and the right. I would say this is about symmetric. And for symmetric, we use mean and standard deviation. Okay, mean and standard deviation. Okay, so with a center, that's going to be the mean of, and I look up here, my mean is 68 inches. And a spread, so for spread I use standard deviation. A standard deviation of, and it gives me that, 4.1 inches. Okay. So that tells me a typical student's a typical student's height is 68 inches, and a typical spread is about 4.1 inches from the mean, which is not that much. So I would say this data is not all that spread out, and you can kind of see 68 here's in the middle-ish, and we go down to 60 and up to 76. So yeah, the heights aren't that spread out, and I guess that's pretty typical of heights in general. One other thing I want to point out, when you have symmetric data, because there's not as many outliers, it usually means that the outliers aren't affecting the mean. So it's frequent that the median and the mean are pretty close to each other. If you look back on the previous page, the mean was actually a little bit higher than the median because there were some of those outliers with higher points values scored. So the mean was brought up by those outliers. So a good thing to look at for deciding if it's symmetric or not is, are the mean and the median pretty close or not? Okay, we're going to finish up with a slightly different problem at the bottom here, number 13. One student took a variety of quizzes. Okay, so one student is taking a bunch of quizzes. Each quiz has 10 possible points. They recorded the results in the graph using a box plot, and we've got all the summary information on the right. Answer the questions. Okay, so the quiz scores have a standard deviation of 2.4 points. What does this mean? Well, for starters, let's talk about how the quiz scores are not very good. The mean was 2.9. Oops. The mean was 2.9. Right there, 2.9. And the standard deviation was 2.4 points. So what I would describe here is that the student didn't do very well. With a mean of 2.9 points. The standard deviation of 2.4 means the scores didn't vary much from the mean. Okay, it didn't vary much from the mean. Another way to kind of look at that, if you do look at the IQR is 3.5 points, 4.5 minus 1. It means most of his scores were right there between 1 and 4.5, 50% of his scores. It's not varying much from the mean. So that's kind of what that standard deviation means. If it had been a standard deviation of like 8, that would mean some of his scores were pretty high. And it looks like he had one outlier here where he was up at 8, but in general his scores were pretty low. Okay, and then finally, just a little reminder question. B says, do we know for sure the student had a quiz with a score of 2? And that 2, well, why is it asking about 2? Well, that's the median. His median score was 2. And no, we don't know that because we don't know if a median is actually in the data set. A median could be the average of 2 data points. So no, the median is not guaranteed to be in the data set. Okay, that's all. Thank you for watching.